Hi, Kinsani. Hello.
Hi, sir.
Oh, we good?
Yes.
All right. Um, just remember what I said earlier on. I'm just going to repeat it. A geometric progression can be identified by a common ratio. And I said to you, a common ratio is simply a fraction. And for you to get the next term, you just have to take the term that you've got and multiply it by the common ratio to get the next term, right? As I've said, a ratio is simply a fraction. So for you to find the ratio, you take the value of the term, you divide it by its predecessor. So you're going to take the value of the term that you've got, you divide it by the previous term. Okay. Now let's say
Yes.
in this ratio here, how would you find the common ratio? And what do you think your common
Uh,
ratio will be?
I'd say T2 divided by T1.
So it'll be T2 divided by T1. And what is R, which is your common ratio?
2.
It'll be equal to 2 because you simply take 6, you divide it by 3, and 6 divided by 3 will be 2, right?
Yes.
All right. What happens when you divide the second term by the first term and the third term by the second term? And it goes on and on. So when you do that, you will always get a common ratio of 2. We good.
Yes.
For instance, if you take 24 divided by 12, 24 divided by 12 will also give you a common ratio of 2. Um, Hence, the sequence or progression is a geometric sequence. So whenever you have a common ratio, that sequence or progression will simply be geometric. Remember, what makes a sequence geometric is the common ratio. What makes the sequence geometric is the common ratio. To get the terms of the sequence, you just need the first term and the common ratio, just like you did under arithmetic. Under arithmetic, you only needed the first term and their first common difference. With respect to geometric sequence, you only need the first term and the common ratio. Now, to get the preceding terms, all you need to do is to multiply by a common ratio. For instance, given the first term of 3 and the common ratio of 2, you just need the first term of 3. How would you get the second term?
3 times 2.
So you will have 3 times 2, right? And how do you get the
Yes.
third term,
Um, would say 6 times 2.
which is 3 times 2 times 2? Do you agree with me?
Yes.
And the next one will be 3 times 2 times 2 times 2. Do you agree?
Yes.
Now, do you agree that this is what you will end up having? It'll be 3, and then the next one will be 3, and then you're going to have 2. The third term will be 3, but you're going to have 2 to the exponent of 2. Do you agree with me?
Yes.
And the fourth term will be 3, but you're going to multiply it by 2 to the exponent of 3. Do you agree?
Yes.
Now, this is the first term, right? This is the
Yes.
second term. This is the third term, and that is the fourth term. We're good.
Yes.
Are you aware for you to get those terms, all you did was simply to take the first term and take the common ratio and simply raise it to the exponent of n minus 1?
So that's when you want to find the other terms.
Yes, this is the general term formula for geometric sequence. Look at the second term.
Uh,
The exponent of 2 in the second term is just 1. And for you to get that 1, it was simply 2 minus 1, which is the second term minus 1. And for you to get this 2 in the third term, it was simply 3 minus 1, which is the third term minus 1. And for you to get this 3 here, it'll simply be 4 minus 1, which is just the fourth term minus 1. Do you get it?
yes.
That's how they got into, that's how they derived this general term formula. Are we still good?
Yes.
All right. So basically, this is what I've just done, and I'm just showing you how they got it. All right.
Okay.
So this is the general term. What is A? What do you think A will be?
A will be 3.
A will be 3, which is your first term. Agreed.
Yes.
And what will R be?
R will be 2.
R will be 2, which is your common ratio. Do you agree? In
Yes.
essence, you only need two things for you to find your general term. You just need the first term and the common ratio. You just need the first term and the common ratio. Are we good?
Yes.
Okay. This is the general term of a geometric progression. And I've just told you, R is referred to as the common ratio. Are we fine?
Yes.
And A is the first term. N is the position. Now here's example 1. Please find the general term quickly.
What is the general term?
The general term is the Tn formula.
TNA equals AR
To the
to the
exponent
power of N minus
minus 1, yes.
1. I don't know if I did it right, but I found the values.
So what did you get?
A is 64.
Yes, what is R?
R is 1/4.
And to the exponent of n minus 1.
Yes.
Are we fine now?
Yes.
Now calculate the 20th term. How would you calculate the 20th term?
I would substitute 20 into N.
Now when you substitute 20 into n, you will simply have 64 divided by 4 to the exponent of 19. We still good?
Yes.
And that will give you, okay, it seems like that is the final answer. Now, if the nth term is equals to 1 over 16, how would you calculate n?
From the same sequence,
Yes, so you will take the same sequence, and what are you going to do?
we're gonna substitute we're gonna substitute 1/16 into Tn.
Into Tn. And how would you go about solving for n? What's the first thing that you're going to do?
We're gonna take 64 to the other side
How
and
do
we're gonna divide.
you're going to divide both sides by 64. And what is 1 over 16 divided by 64?
It's 1/1024.
1 over 1024. it to you manually, all right? Do you understand what I did there when I took 1 over 16 multiplied by 1 over 64?
Yes.
Okay, so you said you're gonna get 1 over 1024, right?
Yes.
Raise that to the simplest exponential form. How much do you get?
4 to the power of 5. I mean, 1 divided by 4 to the power of 5.
And then do you agree with me? You can simply take that 5 outside the bracket.
Yes.
Now the bases are the same. Since the bases are the same, how do you solve for n?
We're gonna say 5 equals n minus 1.
Thank you. And how do I solve for n here?
You're gonna say 5 plus 1 equals n. Therefore, 6 equals n.
We good?
Yes.
Okay. I give you just 5 minutes to do this quickly. You have 5 minutes, okay?
Okay. I'm done. I'm done.
All right. Um, how did you get the general term here?
I said Tn equals AR to the power of n minus 1.
So
And then I substituted,
yes.
oh, then I substituted A equals 3 into the variable A,
What is a?
and then 2, 3.
So I've got 3. And what is r?
R is 2.
So this is all you've got. And then what are you going to do for 2.1?
We're gonna substitute 10 into n.
So I've got T10 is equals to 3 into 2 to the exponent of 10 minus 1. Do you agree with me?
Yes.
What do you get?
We get uh 1536.
1536. Awesome. How do we do
Yes.
2.2?
Um I wrote Tn equals AR to the power of n minus 1.
Yes,
And then the next part I wrote 12,288 equals 3,
yes,
and then in brackets R is T2 divided by T1.
which is 2, right?
Yes,
And this is all to the exponent of n. We good.
yes.
What are you going to do next?
Um, I then divided both sides by 3.
Okay, so these ones cross out. What is one? What is 12,288 divided by 3?
4,096.
So this is equals to 2 to the exponent of n. What is that 4,096?
It's 2 to the power of 12.
It's 2 to the power of 12. And then what are we going to have as n?
So by n, don't we say n minus 1?
Yes, sorry for that. It's n minus 1. You're right. Thank you.
And then I then said 12. 12 equals n minus 1.
Yes,
And then 12 plus 1 equals n. Therefore 13 equals n.
therefore 13 equals n. Perfect. 100%. May I proceed?
Yes.
Quickly, please.
I'm done. I'm done.
So what do you have for 3.1?
Um, I I substituted um 625 into A, and then 1 over 5 into R, and then close bracket 7 minus, I substituted 7 into N, then minus 1.
And what did you get as T? I'm guessing that'll be T7, right?
Yes.
What do you get?
1 over 25.
1 over 25. Awesome. And for 3.2, what did you do?
I substituted 5 into Tn,
So I have 5 is
and then
equals to
625 open bracket 1 over 5
Yes.
close bracket to the power of n minus 1.
Yes. And then what do you do next?
And then I divide both sides by 625.
And what did you get?
And then I get 1 over 25 equals 1 over 5 to the power of n minus 1.
And what do you do thereafter?
Um, there by 1 over 25, it's 1 over 125.
Okay. Um, 125. Am I right?
Yes,
So what did you do?
yes.
What did you get?
And then I said 1 divided by 5 to the power of 3,
1 divided by 5 to the exponent of 3. Yes.
and then equals 1 over 5 to the power of n minus 1.
Yes.
And then 3
Yes.
equals n minus 1.
3 equals n minus 1. And what is n?
N equals 4.
N equals 4. We find.
Yes.
All right. How would you work that out? Can I give you 2 minutes for that one?
Okay. I did it by calculator. I don't know if I'm right though.
All right. What did you do?
I said, since you said that the first term multiplied by the ratio
Yes.
gives you the second term.
Yes.
Since we were given the fourth term,
Mm-hmm.
I divided by
Uh-huh.
3 times.
And what did you get?
189 divided by. I got 63 for the third term.
63 here.
Yes.
And the second term?
Uh, 21 for the second term
Mm-hmm.
and 7 for the first term.
We find.
Yes.
How would you calculate x here?
Um, would say T2
Mm-hmm.
divided by T1
Mm-hmm.
equals T3 divided by T2.
Are we fine? What
Yes.
is T2?
T2 is X.
So what are we going to have? X?
X divided by 16
Mhm.
equals to 4 divided by X.
How do you solve for x here?
Um, I I would say we take the X to the other side
How so?
uh by multiplying
So we multiply by how much?
by X.
Okay. What about 16? Can I do that? So, okay, let me just
Yes,
write it. So I'll
yes,
have x squared over 16 is equals to 4, right?
yes.
What do I do next?
Would say would multiply both sides by 16.
All right. So I'm going to have 16x squared is equal to how much?
X squared equals
Wait,
to
x squared equals to
64.
64. And then obviously you're going to apply the square root. You do know that when you apply the square root, your answer will be plus minus, right?
So if we put a square root, we're gonna have a plus minus
Yes,
answer.
yes. So what will be the value of x here?
Um, we're gonna have positive 8 or a x equals negative 8.
We could
Yes.
write them down. So you've got 16, 8, and 4, okay? And then you've got 16 minus 8 minus 4. Between these two sequences, which one is giving you a common ratio?
The
Is it the first one or the second one?
it's the it's the first one.
So basically, it means that x must be equal to 8. You got it?
Yes.
All right.
But now
Yes?
the second one also gives us the same thing. But now is it that
Uh,
now a ratio can't be
okay.
negative?
No, it can be. So you are right. If it does give you the same common ratio, then x is equals to positive 8 and else can also be equal to negative 8.
Oh, okay.
So you must always go back and check, okay?
Okay.
All righty. There you go. Please try that out. Can I
Okay.
give you 5 minutes, okay?
Okay. I'm done.
Alrighty. What did you do here?
Um, since we have two values of terms,
Yes.
which is term 3 and term 6,
Yes.
I did a simultaneous equation
That was good.
where, whereas Tn equals AR to the power of n minus 1.
Yes.
Therefore, 5 equals AR3, I mean to the power of 3 minus 1.
Yes.
Therefore, 5 equals AR to the power of 2.
Thank you. This will be equation number one. And what's next?
Yes. And then I said Tn equals AR to the power of n minus 1.
Mm-hmm.
That's now equal to 1 divided by 25 equals to AR to the power of 6 minus 1.
Mm-hmm.
That's now 1 divided by 25 equals AR to the power, sorry, to the power of 5.
And this will be equation number two. And then what did you do?
I said equation 2 divided by equation 1.
So you set equation two divided by equation one. Okay. So it'll
Um,
be 1 over 25. You divided this by 5. It'll be equal to AR to the exponent of 5. You divided this by AR to the exponent of 2. Am I right?
yes.
And what did you get on the left-hand side?
On the left hand side, I got 1 divided by 125
Is equals to.
um r to the power of 3.
So am I right to say you did that?
Yes.
So you have, what is the value of R now?
The value of r equals 5.
No.
I wrote 1 divided by 5 to the power of 3.
This is correct. So all you had to do was simply to apply the cube root on both sides. You get it?
Yes.
So R is equals to 1 over 5. Do you agree with me?
So isn't r equals 5?
No. What is the cube root of 1 over 25? I mean, cube root of 1 over 125.
Um, oh, I thought you're supposed to like do it the way we did it on the other ones, whereas we put it as 1 divided by 5 to the power of 3.
So, okay, let's do it that way. So if you do it that way, you're going to have 1 over 5 all to the power of 3, right? Is equals to R. Do you agree? R to the
Yes.
power of 3. If the exponents are the same, you just drop the exponents and you equate the bases. It still gives you 1 over 5.
Oh, oh, okay.
Remember, when the bases are the same, you equate the exponents. It still works the same way with exponents. When the exponents are the same, you drop the exponents and you equate the bases.
Okay.
Good. Now,
Yes.
we're not done yet. Once we found the value of R, what do we still need to find?
We still need to find A.
So how are you going to find A since you know that R is 1 over 5?
We're gonna substitute R into one of the equations that we got.
Which equation do you want me to use?
5 equals AR to the power of 2.
However, where there is r, what am I going to substitute?
We're going to substitute 1 over 5.
All right. So what do you get as a?
A is 125.
A is 125. Perfect. Now, since we've got a, I've got 125 as the first term. What will be the second term?
We're going to say 125 times 1 over 5.
How much does that give you?
We're going to get 25.
We're going to get 25. And what is the third term?
We're going to say 25 times 1 over 5.
How much?
And then we're going to get T3 equals 5.
It is equals to 5. But we find out these are the first three terms that they wanted.
Yes.
Can I move on?
Yes.
Please do that one quickly as well. 5 minutes.
I'm done.
What did you do?
I did a simultaneous equation, whereas of Tn equals AR to the power of n minus 1. That's equal to 4 equal to AR to the power of 4 minus 1. That's now equals to 4 equals AR to the power of 3. And then the second one is Tn equals AR to the power of n minus 1 equals to 1 divided by 16 equal to AR to the power of 7 minus 1. Then 1 divided by 16 equals AR to the power of 6.
Okay, are we done?
And then I said 1 divided by 16 divided by 4 equals to
Wait a bit.
A.
You said what? 1 divided by 16 divided by 4.
Yes,
And then,
equals to AR to the power 6 divided by AR to the power of 3.
and what do we get?
We get 1 divided by 64
Okay,
equals to R to the power of 3.
okay.
And then I I then said 1 divided by 4 to the power of 3
Mm-hmm.
equals to R to the power of 3.
Mm-hmm.
And then 1 over 4 equals R.
Awesome. We good.
Yes.
Calculate the first, well, we're not there yet. Calculate A.
And then I said I took the equation 4 equals AR to the power of 3. Then I substituted 1 over 4 into R.
Yes.
And then I said 4 divided by 1 over 64 equals A.
And what did you get there?
And then I got 256.
Right above A.
Yes.
So if 256 is my first term, what will be my second term?
And then I said T2 equals 256 times 1 over 4, which is the ratio, common ratio.
Yes.
And that gives me 64.
Okay, the next one.
And then T3 equals 64 times 1 over 4,
Mm-hmm.
which equals to 16.
Are we still good?
Yes.
All right, those are the first three terms that they wanted you to calculate. May I proceed?
Yes.
Now here they said a geometric series is the sum of all terms in a geometric progression. So when we add all terms in a geometric sequence, we will get what we refer to as a geometric series, okay? Given the following geometric progression where we have 4 plus 8 plus 16 plus 32, it will be written as okay, let me just write it quickly. So 4 plus 8 plus 16 will be written as the sum of the first 8 terms. And when you add them up, you will simply get 4 plus 8 plus 16 plus 32. How much does that give you?
It gives us 28.
It gives me how much? 28. So the sum of,
Oh, plus 32.
did you add 32?
That'll be, that'll be 60.
Okay, thank you. All right. Are we together there?
Why are we saying S8?
Um, I don't know why I'm saying S8. It's supposed to be S4. We good?
Oh. Okay.
from finding the sum of the
Yes.
first four terms. When you add them up, it will simply give you 60. And that 60, we normally refer to it as the geometric series, because we've added. Geometric series is where we add the terms of the sequence. We good?
Yes.
All right. I will not derive the formula. I'm just going to give you the formula later on. Calculate the sum of the first 11 terms of the following geometric progression. Do you see when you add the four terms, it's pretty easy. But when they say calculate the sum of the first 11 terms, it becomes a problem. Do you realize that?
Yes.
That's where you need to use the sum formula for a geometric sequence, which is simply Sn is equals to A into 1 minus r to the exponent of n divided by 1 minus r. And you need to make sure that r is not equal to 1. Are we good?
Yes.
For me to use this formula, I need the value of A. What is the value of A here?
Uh, 2,401.
It's 2401. I also need the value of r. How do I find the value of r?
We're gonna say T2 divided by T1.
T2 divided by T1. What is the answer?
We get 0,42. I mean 0,14.
0, comma 4.
14.
Let's do it quickly. So you took 343, you divided it by 2401. Please leave it as a fraction. How much do you get?
1/7.
1 over 7. Is that what you got?
Yes.
And then you also have to be given n. They told you that n is equal to 11, right?
Yes.
So in total here, you only need the value of A, the value of R, and the value of N. If they don't give you one of these, they must at least give you Sn. Do you get it?
Yes.
So there's always four of them. They must always give you three. You got it?
Yes.
So for me to calculate S11 here, it will simply be equal to, where there's A, I will substitute 2401, and where there's r I will substitute 1 over 7, and where there is n I will substitute 11. Okay, and
Yes.
divide this by 1 minus 1 over 7. How much do we get as the sum of the first 11 terms?
Um, I got 2,801.
2801. No decimals at all.
They are
Two decimals,
uh, 0,17.
17.
Yes.
Fine.
Yes.
All right.
So now, for the value of SN,
Mhm.
are we allowed to get like a decimal answer?
Yes, you are.
Okay.
I hope we could.
Yes.
All right. This is what you need to do. May you please try the first one here?
Okay.
I'm going to give you 3 minutes, okay?
Okay. I'm done.
All right. I'm just going to go straight to it. So you've got S what?
Um, Sn equals a open bracket 1 minus r to the power of n
Mm-hmm.
divided by 1 minus r.
Mm-hmm. Just remember to write this rule. And then what did you have?
A was 5,
So it's S
so
what?
Sn
S13
is 13
equal
equals to 5 open bracket 1 minus 12, I mean 1 minus 2 to the power of 13, and then divided by 1 minus 2.
2 to the power of 13. You said 2 to the power of 13
Yes,
divided by 1 minus 2.
yes. And then I got um 5 open bracket negative 8,191
Mm-hmm.
close bracket divided by negative 1.
So it's 5 open brackets negative.
Negative 8,191
Yes. Divided by
close
negative 1.
bracket, and then the answer is 40,955.
Any questions with respect to that?
No.
Please do number 2 quickly.
Done.
All right, give it to me. What do we have?
Um, the value of A is 729.
So we've got S what? All right, let's start with
S
Tn. What did you get as Tn?
N.
Yes?
Um, Tn equals to, is it AR? AR N minus 1.
Mm-hmm.
And then A is 729.
Yes.
And then R is negative 1 over 3.
Yes.
And then to the power of N minus 1.
All right. And then 2.2, how do we find the sum?
Um, I said Sn
Yes.
equals to 729.
Okay. One, immediately you substitute. You can't say Sn.
So do I first write the equation?
Yes. But then it will be S what?
Oh, S16.
S16.
Yes.
S16 is equal to,
Is equals to 729
yes,
open bracket 1 minus uh 1 divided by 3 to the power of 16.
and this is divided by 1 minus negative 1 over 3, right?
Yes.
Get to the final answer. What do you get as S16?
I get 546,75.
Isn't there a way of writing it as a fraction?
Um, let me see.
Nothing.
I'm still trying it again.
Okay.
No.
All right. It's fine as it is, okay?
Okay.
Please write all of these. And this is where we're going to stop for today. Can I please have them by tomorrow if possible?
Okay.
When are you writing again?
On Tuesday.
On Tuesday. So we still have tomorrow.
Yes.
Tomorrow I am, at what time do you normally get home?
I get home at 2
At 2.
or like quarter past 2.
Can we meet at 3 then?
Yes.
All right, tomorrow at 3 o'clock, okay?
Okay. And there's like a sum in the, I don't know, in like the textbook.
Yes?
Whereas I don't understand how I'm supposed to do it.
Please send it to me. Take a pic
Okay.
and send it, and then we're gonna start with it tomorrow.
Okay.
Enjoy the rest of your Sunday.
You too, sir. Thank you.
You're welcome. Bye bye.
Bye.